In these last few videos, we've been walking through the different derivatives of carboxylic acids. Carboxylic acids have that carbon double bonded to oxygen, so that carbonyl, and the carbonyl carbon is bonded, in the case of a carboxylic acid, to an alcohol, an OH. And in this video, we're going to talk about how to name a different carboxylic acid derivative. If you take a carboxylic acid, that OH can act as a leaving group, and if you replace it with an ether, so an OR, where R is any carbon chain, then you get what's called an ester. So this is an ester here. Now, really you make that by having this carbonyl react with an alcohol as opposed to water. You could imagine having water come in and do a proton transfer, turn into the OH. Remember, if you replace one of the H's on water with a carbon chain, you get an alcohol, and you could imagine that coming in, doing a proton transfer to lose the H, and giving you this ester. So these esters are very common in living things because water is extremely common, and you just have to replace one of the H's in water with a carbon to get an alcohol, and you use the alcohols to make these things, to make these esters. And so things like triglycerides, or fragrances, like the smells of fruits or perfumes and flowers, those are esters. Okay, well, how do you name an ester? It's a little tricky because you have two parts. You have a carbon chain that it has the carbonyl, and that's going to be named as the backbone. And actually, let me do that. That'll be named as the backbone, and the suffix for that carbon chain with the carbonyl will be O8. You do, however, have another carbon chain, the R group, on the other side of the R group that does not have the carbonyl, on the other side of that sort of ether. And that's going to be named as a branch. So it will have the suffix YL. You'll just have the prefix, and then immediately after the prefix you'll have a YL. Now notice, which one is the backbone does not depend on which one is longer. It depends on which one has the carbonyl. The carbonyl is the backbone even if it's shorter, and the other one that doesn't have the carbonyl is the branch even if it's longer. So let's do a couple naming for these. So here's a molecule that's responsible for the smell of pineapples. Let's name that molecule. So if you had this oil, an oil of just this molecule in a room, it would have a strong smell of pineapples even if not a single pineapple was around. Well, we have two carbon chains. We have one carbon chain that has the carbonyl, and then we have another carbon chain that doesn't. So we're going to name the carbon chain that does not have the carbonyl as a branch. And this has two carbons, so the prefix is eth, and because we're naming it as a carbon branch, it will end in YL. So that blue part will be named ethyl. The orange part, the carbon chain that has the carbonyl in this ester, is going to be named with the suffix. So it has 1, 2, 3, 4. 4 carbons, that's bute. In between the carbons, outside of the functional group, so if you just look at the bonds between the carbons that are not represented in the functional group, it's all single bonds, and so the infix will be AN. And finally, we have an ester. We have a carbonyl with an ether on one side. That's an ester, and so the suffix that we're going to use here is O8. So butanoate is the backbone name, and the branch name will be ethyl. So the full name for the compound is ethyl butanoate. The molecule that's responsible for the smell of pineapples is ethyl butanoate. Okay, let's compare that with this other molecule responsible for the smell of oranges. You have two parts. You have a part that has the carbonyl on it. You have two carbon chains. Carbon chain that has the carbonyl on it, and you have a carbon chain that does not have the carbonyl on it. The carbon chain that does not have the carbonyl on it will be named as a branch. Now here we have 1, 2, 3, 4, 5, 6, 7, 8 carbons. The prefix for 8 carbons is oct, and because we're naming this as a branch, immediately after that prefix you'll have a YL. The part that has the carbonyl, that has only 2 carbons. The prefix for those 2 carbons is eth. Outside of the functional group, which will be named in the suffix, you have only single bonds, so the infix is AN, And then because this is an ester, the suffix is -ate. And so the name for this compound, put the branch name in front of the backbone name. The name for the overall compound is octyl ethanoate. The molecule that wiggles its way into your nose every time you smell an orange is octyl ethanoate. All right, here's another ester. It's responsible for the smell of apples. So here we have a carbon chain that does not have a carbonyl on it. Then separated from that through the oxygen is another carbon chain that does have the carbonyl on it. So those are going to be named separately. The carbon chain that doesn't have the carbonyl, this in blue, is going to be named as a branch. Now there's only one carbon there, so the prefix for one carbon is meth. And because we're naming this as a carbon branch, immediately after that prefix will come YL. For the other half of the molecule, here, the part that has the carbonyl, we have 4 carbons. The prefix for 4 carbons is bute. Outside of the functional group, just in the area that doesn't have that carbonyl or the other oxygen, outside of the functional group, it's all single bonds. So the infix is AN. And because this is an ester, the suffix will be -ate. Because this has a carbonyl with an ether on one side, the suffix is -ate. So you take the branch name and you put it in front of the backbone name, and the whole name for this molecule, the molecule that's responsible for the smell of apples, is methylbutanoate. So if something like Yankee Candle or some candle company is trying to make an apple-scented candle, they'll take the wax that's unscented and they'll mix some methylbutanoate in it. And anytime you bite into an apple and you smell the fragrance of it, you're smelling that because trillions upon trillions of methylbutanoate molecules are wiggling their way, dashing into your nose. So hopefully this gives you a sense of how to recognize esters and how to name them with their 2 carbon branches.